Hello and welcome to the AI Research Roundup. I'm Alex. It's May 8th, 2025, and today we're discussing an ICLR conference paper called BigCodeBench, Benchmarking Code Generation with Diverse Function Calls and Complex Instructions, published just over 3 months ago. This paper introduces BigCodeBench. It's a new benchmark, essentially a tough exam for large language models, or LLMs for short. Large language models are advanced AI systems, and this new benchmark tests how well these large language models write Python code for complex, practical tasks. It really pushes them by requiring many different function calls, like pre-built coding tools, and understanding very detailed instructions. Alright, so to see how BigCodeBench delivers these detailed instructions and uses diverse function calls, let's look at Figure 1. It shows a sample programming task. We see backquote, import backquote statements for libraries like backquote, HTTP client backquote. These are the tools the AI might need. The task itself is a function with a detailed docstring. A docstring? That's a special note explaining the code, its parameters or inputs, expected outputs, and requirements. Crucially, the figure also highlights a test case class, which is a set of automated checks ensuring the AI's solution works correctly. This comprehensive setup really tests the models thoroughly. Now, this next figure illustrates how these challenging tasks in BigCodeBench are actually created. It's a 3-stage process, really emphasizing a human large language model collaboration. First, there's data synthesis, where an initial code idea gets expanded by a large language model, GPT-4 in this instance, into a more complex programming task. Then, in the program refactoring and test case generation stage, humans and the large language model work iteratively, refining the task and building out those crucial test cases with feedback. Finally, human curation provides the last quality check, with people carefully reviewing and cross-checking everything. So after seeing how these tasks are put together, this figure breaks down the types of coding challenges involved. We see different domains which are just specific areas of programming like computation, general, or even networking. For each domain, it lists example libraries, those collections of pre-written code, and specific function calls. The percentages, like 63% for computation, tell us how many tasks use tools from that particular area. This diversity really highlights how BigCodeBench pushes large language models to work with a broad toolkit, a skill where they currently lag significantly behind humans. Building on that, this figure illustrates 2 different ways tasks are presented to the large language models. On the left, we have the complete prompt, which uses that structured docstring format we saw earlier, very detailed. On the right, there's the instruct prompt. This one is more like a natural language request, transformed from the complete version by removing some details. The researchers found that large language models are quite sensitive to this difference in instruction verbosity, or how wordy the instructions are, generally performing worse with the less detailed instruct prompt. So we've seen how sensitive large language models are to instruction details. This next figure really puts BigCodeBench into perspective against other existing benchmarks. These are other standard tests for code generation. It's a chart plotting depth complexity on the vertical axis, essentially how intricate the problems are, against breadth tool on the horizontal axis, which indicates the variety of different coding tools or libraries needed. And you can see BigCodeBench marked with a star way up in the top right. This position clearly shows it's designed to be significantly more complex and demand a much wider range of tools than the other benchmarks displayed. Alright, so we've established that BigCodeBench is really pushing the boundaries. This next figure dives into how current instruction-tuned large language models, these are models specifically trained to follow instructions, actually fare. We see 2 bars charts, the top for BigCodeBench Complete with its detailed prompts, and the bottom for BigCodeBench Instruct. The bars show the pass at 1 score. That's the percentage of problems these large language models solved correctly on their first attempt for various models. Even the best, GPT-4o, reaches only about 60% on Complete and under 50% on Instruct, far from human performance. So what this all really tells us is that while large language models are getting incredibly smart, there's still a noticeable gap. A big one, actually, when it comes to tackling these really complex, practical programming tasks that need a lot of different tools. And as we saw, they're also quite sensitive to exactly how you ask them to do things. BigCodeBench, then, really shines a light on where future research needs to focus. Thanks for tuning in to the AI Research Roundup, and I'm Alex, signing off.